This is part 3 of the calculus review video, of the geometry review video. We'll pick you up with question number 16 on the Chapter 9 review. We have all this information here, all these labelings and lengths, and they want us to fill some things in here. First of all, I notice the big triangle is a right triangle. You could use the Pythagorean theorem, but this is an 8, 15, 17 triangle. So BC is 8. They want me to find the length of AD. Well, notice here that ED is half the length of BC. So this little triangle in here is similar to the big triangle. Basically, there's a 1-to-2 ratio between the two triangles. And so what that suggests is if this whole side is 17, half of that would be 8.5. That's going to be the length on that side. If this is 15, half of that's going to be 7.5, and that's that upper triangle. And then, of course, we can figure out that this would be 8.5, and DC would also have the length of 7.5. All right? And we've got just a couple more in the book. 17 was a distance formula. You can subtract the x's and square, subtract the y's and square. Pretty straightforward. So that's going to be 4 minus 1 squared plus, and you're going to get 15 minus 11 squared, and then the square root. 4 minus 1 is 3. 3 squared is 9. 15 minus 11 is 4. 4 squared is 16. Ends up being the square root of 25, which is, in fact, 5. All right. And finally, the boat question. Let's look at the wording of this one. It's kind of a neat problem. It's a little bit counterintuitive. So you have a boat here, and it's tied to a pier by a 25-foot rope. We can see that right here. And the pier is 15 feet above the water, or at least 15 feet above the top of the boat, I guess. And it says if 8 feet of rope is pulled in, how many feet would the boat move? Well, you know, your general thought would be that if you pull in 8 feet of rope, that the boat would move 8 feet. But does it really? So we come over here. I'm going to draw the original position, and I think they're actually saying that this height goes to the top of the dock. I don't think the picture was actually drawn perfectly based on what their solution is going to be. So anyway, the point here is you can make a right triangle with a length of 15 and 25. And as a result, you should be able to figure out horizontally how far this boat is from the dock. This little 3, 4, 5 triangle with the 4 side, all the sides are being multiplied by 5. So the 4 side is being multiplied by 5. Basically tells you the boat is 20 feet away from the dock. Okay? Now, if you pull in the rope, you're pulling in 8 feet of rope. That means your rope is only going to be 25 minus 8, which is 17 feet after that. So now you have a rope that's 17 feet, and you have your little boat, and the boat has come in some. Dock is still 15 feet high. So we've got this right triangle here now that is an 8, 15, 17 triangle. So the boat was 20 feet away from the dock. Now it's 8 feet away from the dock. 20 minus 8 tells us this boat moved 12 feet when that rope was pulled in 8 feet, which is kind of interesting. Might not necessarily be what you expect.